Decision theory. During probability theory, we had said that once you understand probability theory completely, and then once you know about probability theory, if you learn decision theory as well, you will be in a position to make the right decision using your models. That is, let us say using probability theory, you understood the joint probability P of, let's say, xt, where what is this x? X is the input, that is, x may be divided into x1, x2, x3, all these components. This combinedly makes this x, which is the input. And t, what is t? T is your target. This is your target. That is, when you get data, there will be x and t, and it will be like this is the training data that you have. In that, for this value of x, this is the target value t. This value of x, this is the target value t, and so on. What is your task? From this training data, your model should learn how to map these x to these t's, right? Once you understand that, if a new value of x is given for which there is no value of t as of now, our model should be able to predict the value of t. That is the whole idea. So what the probability theory does is, it provides a summary of uncertainty associated with the variables using this joint distribution. That is, once you have this joint distribution P of xt, from this you will get a summary of the uncertainty associated with the variables. And once you know this probability, you should know what decision to make. That is, from this, your model will tell you that this is the target variable that is expected. From the idea of understanding of t, you should be able to finally make one decision. Let us take an example and understand this, then it will be easier. Let us say your use case is like this. That is, the input variable, you want to identify whether in the border someone who is approaching you is an enemy or not. That is, if it is an enemy, what you want to do, let us say this is the border of a country or something like that, and you have, let's say, installed security cameras all over here. There are a lot of security cameras here, and these cameras keeps watching whoever is approaching. Now let's say there are some people approaching, camera noted these people. Once these people are noted, the camera has to identify whether the ones who are approaching, whether they are enemies or not enemies. If they are enemies, what do you have to do? We have to send our troops to that area so as to protect. And if it is not an enemy, then no issue, we can keep our troops wherever they are. So the whole final decision is whether to send the troops or not. That is the decision we have to make. And for that, what is the probability we have to find? First, we have to find whether they are enemies or not. Based on this probability, whether they are enemy or not, we have to make this decision. What is the decision? Whether to send the troops or not, right? Let us write these things down. What is your input here? Let us say the input that you get from camera, that you have divided into multiple subcomponents. Let's say you're looking at this is your X, which includes, let's say, dressing of the people who are approaching, maybe the items that are there in their hands, and maybe the bag that is there in the shoulder, and maybe their body language as well. Okay, these are the things that are your input items. That is, from the pictures that you have in camera, you identified these particular inputs, and these are the inputs that will go to your model. First thing is dressing, the dress code that they are following. Second thing is the items that they are having in their hand, then the bag in their shoulder, and the body language. We are just taking an example just for understanding. Okay, and what is your target T? It is presence of enemy, right? Your target is presence of enemy. This is your target. So once you identify this target, there should be an action. What is your action? Action is to send troops or not, right? Send troops or not. This is the action that you have to take. How will you take this action? First thing is, once you take the X, the input variable, you should be able to identify it into one of the two classes, C1 and C2. C1 says presence of enemy, right? This is your C1. And what is your C2? C2 says, let's say, not an enemy. Okay. So you have to first put this into one of these two classes. Once you get the X, using this, you should be mapped to one of these two classes. Based on the class, after that, using decision theory, you have to make the decision of whether to send troops or not. So the probability theory will tell you whether there is an enemy or not, whether it is identified as an enemy or not, and then decision theory will tell you whether to send troops or not. This is the whole setup. Let us say in this particular problem, we are having target as t equal to 0 or 1. Here, let us say 0 is mapped to class C1, 1 is mapped to class C2. So what is C1? C1 means presence of enemy, C2 means not an enemy. So if there is an enemy, you have to send troops. That is the whole idea. What will you first find? First thing that you find is the probability distribution. So what is the probability distribution here? It should be like this. P of X is your input and what is your class? CK, right? And in order to find this, it is equivalent to finding what? P of xt. T is your target variable. Target variable is mapped one-on-one with the class, right? T equal to 0 maps with class C1. T equal to 1 maps with class C2. So whether you find probability of X CK or probability of xt, the final effect is one and the same. How will you now find this? You will use Bayes theorem. How will you find using Bayes theorem? This is what you have to find. You have to find P of C1 given X and P of C2 given X. These are the two things you have to find. What is C1 given X? X is the data. Given the data X about this particular set of people, whether they belong to class C1, that is, are they an enemy, or do they belong to C2, are they not an enemy? This is what you have to find. Given X, you have to find the class. This is the task. So how do you use Bayes theorem for this? P of, let's say there are k different classes. Here we have only two. CK given X. How will you find this? This is equal to probability of, we are using Bayes theorem, okay? How do you expand this? X given CK into probability of CK. What is this probability of CK? This is the prior probability, whole divided by P of X. So as we discussed previously in Bayes theorem, in Bayesian probability model, what do? You use a prior. This is your prior. What is prior? Before you see the data, before you see X, you have fixed that the probability of C1 is something and probability of class C2 is something. How will you identify this? See, normally, let us say, if you have 100 people coming in who are detected in the camera, most of them won't be enemies. They will be civilians. So in that case, let's say C1 is enemy, C2 is not enemy. In that case, probability of C1 will be very less because chances of enemy, let's say it's only 1%. And let's say 99% chances that there will be a civilian. Let us say this is the general statistic that you have. So from this, you know the prior probability. Before you see the data, you know that probability of C1, that is being an enemy, is 1% and not an enemy is 99%. This you will feed here as prior probability. Once you have the prior probability, what will you do? You have to find posterior. This is the posterior. Posterior will be influenced by the prior as well as the data. Data is X. Using X and using the prior, you will find the posterior. This posterior will give you the probability that given this particular data, does that belong to class C1 or C2? If they belong to C1, it is detected as an enemy. If they belong to C2, they are detected as not an enemy. So whatever be the detection, once you detect it, you have to make a decision. What is the decision? Decision is to send troops or not send troops. Okay. This is the decision that you have to make. How will you make this decision? There are two approaches. This is what the whole gist of this decision theory is. Okay. Once you find the probability, once you know the posterior P of CK given X, if you identify that, there are two different approaches. First approach says minimizing misclassification rate. That is, you have C1 and C2 as two different classes. So you have to identify that approach which will minimize this misclassification rate. That is, most of the point will be identified to the right class. This is the first approach, that is minimize misclassification rate. Misclassification rate. So this approach is the approach using which you will classify most of the points to the right classes. And what is the second one? Second one is minimizing expected loss. So what is the difference between these two? See, loss may not depend just on the classes. It may also be dependent on how important is this decision. That is, if you make a decision that this is not an enemy, but it turns out to be an enemy, that is a very high risk event. But if, let's say, it was actually not an enemy, but you classified it as an enemy, the risk is lesser. The only thing that will happen is you will have to send extra troops. So there is this comparison that you have to take into care, and accordingly your expected loss will differ. So this minimization of expected loss, this particular approach will take care of all those. And the approach of minimizing misclassification rate, what this does is, this will make sure that every single input data point, it is most of those data points are given to the right classes. If it belongs to C1, it is given to C1. If it is belong to C2, it will be given to C2. So in the coming two lectures, we will see in detail how these two approaches differ. That is, if we minimize misclassification rate, in what scenarios can that be helpful? And if we minimize expected loss, in what scenarios will that be helpful?